Hey guys, Kevin here and welcome back to the machine learning course. In this video, we're going to be having a look at regression. We're going to be having a look at 6 types of regression, that is simple linear, multiple linear, polynomial, support vector, region tree and random forest regression, right? Don't worry, we're going to be covering it, each one of them in detail. So for this entire video, we're going to be using the house price prediction dataset. We covered it in the previous video. So over here, what the house price prediction dataset basically is that you've got loads of factors and the corresponding price of the house. So they took one house, its price was 3,13,000 dollars probably, and then they listed everything, that how many bedrooms it has, how many bathrooms it has, what is the living square feet area, what is the lot square feet area. All of those factors were given, and the corresponding price is also given. And this is a very big data set. We have loads and loads of data for it. So now what we did was we performed pre-processing on this data. We did some encoding and all of that, and at the end we found out the mutual information scores, that is feature selection, and we came up with a cutoff of 0.1. All right, so according to this cutoff, our data set will just have 4 factors, that is living square feet, city, above square feet and bathrooms, and these 4 factors affect our house price by a major percentage. They have quite a bit of effect on the house price. That's why we are just going to use these 4 of them, right? And the price obviously. So we shrunk, or we compacted our data set to just 4 factors for this one target. All right, and now we are going to do regression and different types of regression on this same data set. All right, so let's start with simple linear regression. What simple linear regression? Okay, before we do that, let's have a look at regression. What is regression? Regression is basically the process where you try to find a relationship between these factors and the target. You try to find a relationship between them, and then once, based on the data that you have been given, once you find that relationship, what you can do is you can put your own customized inputs into the model, and then according to that relationship it will put these values and give you an output variable. All right, so let's say you have a line y equals to mx plus c. All right, you must have done this in your 11th, 12th or maths. You must have done this, where let's say you create a line y equals to mx plus c. You've got the constant value c, you've got the slope m, and in that equation you will put the x as your input, and then you will receive a corresponding y output. So it's similar to that. So how simple linear regression works is that for simple linear regression we just use one feature. So it's just one feature plotted on the x-axis versus your target, which is plotted on the y-axis. All right, so you got house price over here, and then we just had to select one feature. So we selected the square feet living because it affects the house price the most. Right, so what we did was we created x as all the rows and column at index 1, so that's your square feet living column at index 1, and then y was our target, was all the rows and the column at index 0, so that's your price. So x and y were created. Did the splitting, we split our data set 80% training, 20% testing. Right, so let me just run these. And when we printed these x train y train, we received these. So our training data set has 3680 houses, right, and our testing one has 920 houses. So once our model has been created on these 3680 houses, we'll later then test them on these unseen values. All right, so model is trained using these 3680 values, and then the model doesn't know about these new values. All right, so what it will do is it will using the training that it has done, it will give these values as an input. We will receive an output as well. So corresponding to these values, what the model thinks is the answer. So let's say for 2330, the model thinks the answer is, let's say, 40,000. All right, and then what we'll do is we'll compare it, that if the model gives the answer as 40,000, what is the real answer, and then in that way we could also prove how accurate the model is. All right, so let's do that. Now first of all, when we are doing regression, we need to convert these data types into arrays. All right, so right now we have got these as columns extracted from an entire data frame. We need to convert them to an array so that like the regressor can work with it. So for that, we are going to be using the reshape function. All right, so take the extrain values and then just reshape them to -1 comma 1. What that will basically do is it will convert it to an array. So let me just run this, and when I will print x train y train now, you can see that instead of being a column, it is now a proper array. So our machine would be able to work with these values now. I'm just print this as well. Yeah. So that was reshaping. All right, you need to do that in most of the cases. Now we are gonna import the linear regression module, the linear regression from the sklearn.linear underscore model module. We're gonna import that pack, and then from that pack, since that has been imported now, we're gonna create a variable called regressor, and we'll assign it the linear regression function to it. Alright, so that's done. And then in the regressor, we're gonna fit. So we're gonna fit the regressor model using the X train and Y train values. Alright, so the training 3680 values that we had, we're gonna give it to the model that, hey model, here have these factors as your input and then have this as your output. So whenever this was the input to you, you should be giving this as your output. So just let's fit our regression, and it shows it's a success. All right, so now at this point our module has been given 3680 values as input and 3680 values as the desired output. It has been trained. All right, now what we're going to do is we're going to find the predictions it can make. So based on the testing unseen database that we had created earlier, we're going to ask the regressor to predict for those values, and then whatever prediction it comes up with, it should store it in a variable called y underscore pred. Alright, and then we're going to print y underscore pred to have a look at it. So there you have it. For each value given as input, for each of the 920 values given as input, you have received an output based on the linear regression. Now to understand it, we'll visualize it. All right. So let me just run this. So you got a price versus square feet graph over here. So what we did was each house over here is indicated by a red dot, and each house has been printed over here as a red dot. And then based on the way these red dots were, accumulated on the graph, we did a linear plot. All right, we got this line. Now, for when we did the predictions, when we created y underscore pred, what it did was it gave the input. So let me just go to x underscore test over here. All right, yeah. So I need to scroll up for a bit, or else I could just go over here. Yeah. All right. So x underscore test. Let's say it was 2330. All right, 2330. So in our graph, 2330 somewhere over here. So according to 2330, it was given as input on this blue line, and whatever corresponding value on the y-axis was found, that was printed over here. That was printed in the y underscore pred, and then that is just how it works. Now let's visualize the test set results as well, and you can see that there's a difference in the training and testing where uh, based on the training training data set, this is the linear line that we have found, and based on the testing data set, this is the linear line that we have found, right? So that's pretty much it. That's how linear regression works. Let's move on to multiple linear regression. So now what multiple linear regression is that over here in the above case, we just took one factor, that was living square feet. However, as we saw above, we have four significant factors. So what we'll do is we'll create x, but then we'll make it so that it has all the factors, all the four factors. So all the factors after the index 0, from index 1 till the end of the entire data frame. So x will have those factors, y will obviously be our price, and let's split it again. Let's run this. Let's import the linear regressor as before. Let's do one thing. Let's have a look at x and y so that we can uh, print x, print y. Let's run that. Alright, so X is square feet living city, square feet apartment bathrooms, where Y is just one output. Alright, so that's what we wanted, right? And then let's fit X train and Y train, right? And now let's make the predictions. So there you have it. Based on the yeah, so when we perform this split, let's visualize the split. All right, so let's print x underscore train. Let's print y underscore train. Let's also print x underscore test, and let's print y underscore test. Let's run this. Yeah, so we have got 3680 rows, all right, as before, and 920 rows in the testing data set. And then we did these predictions on the testing data set. So let's say for uh, 2330171190 when these four factors were given as input to a regressor model, we received the answer as 590977 and so on. All right, and let's plot these. So let's plot y test versus y pred. So whatever value was actually found, all right, which was actually present in the data set versus what was predicted, and you can see that it kind of follows an x equals to y line. All right, kind of, most of them do. All right, so that's how accurate our model is. So that's basically how multiple linear regression works. All right, you this is just this code that you should understand, and you can do these plots as well. uh, let's move on to polynomial regression. So polynomial regression is pretty similar to the simple linear regression, where you take just one factor and one target, all right, and then instead of making a linear line, you make a polynomial line. So it's x square plus x cube plus something like that, all right. Instead of it just being y equals to mx plus c, it is y equals to ax cube plus bx square plus cx plus d, something like that, all right. So let's do the same process again. Let's again convert these x and y values to arrays, and then let's put them in the polynomial regression model. So again, you'll perform linear regression. All right, you'll also fit x and y on the linear regressor. So let's run that. It tells us linear regression has happened. Now what you do is, what difference it is, from scikit-learn.preprocessing we'll import polynomial features, and then we'll create a poly underscore reg variable which will create a polynomial function of degree 4. Alright, you can customize the degree of the polynomial that you want, and then we'll fit it based on x, and let's just run that. Yeah, so what we did was we did a transform on x so that we can do the polynomial regression, and then we found a linear regressor underscore 2 which was fitted on x underscore poly and y, and then let's visualize it on the graph so that you can understand it better. Yeah, so as you can see over here, we did the same plot, and then instead of it being a straight line, it is now a polynomial line. All right, so let me just go above to linear regressor graph. You can see over here it was a straight line. Instead of it being a straight line, here it is a polynomial equation. All right, so now in this equation, whatever x value you give, you supposedly should get an answer as y as well, right? So that's polynomial linear regression. So let's have a look at support vector regression. In this method, what we do is we create the entire plot of all the values on the xy plane. Alright, so you have got on the x-axis again the living area, and on y-axis the price of the house. And based on this entire plot, you try to create a line. Now this line divides the entire data set into two parts. One part contains all of the houses that are predicted to have a lower sale price based on their living area, and then the other side contains all the houses that are predicted to have a higher sale price based on their living area, and that's the two groups that we have created. Now, once the line has been found, once the entire line has been plotted, now let's say we have the input house, a new house, which has a living area of 1500 square feet. Now, based on the support vector that we just created, we will see the position of the 1500, like wherever of the new house, wherever we plot it, how far it is relative to the line, and then based on that position, we'll predict its new price. All right. So let's have a look at the code. All right. So let's first take our x and y. X is again the living area, and y is your house price. Let's print x and y, and then let's reshape them so that we can work with them as arrays. Now for this method we do feature scaling. I have explained feature scaling in the previous video, so you should have a look at that. Feature scaling, we'll just run this code so that we can do the feature scaling on it. So now x and y have been scaled properly. If I were to print x and y, you will be able to have a look. Just run this. And so these are the new scaled values of x and y. All right. And now we're going to train the support vector regression model on these new on these scaled values. All right. So for that we'll import SVM, support vector machine, from scikit-learn, and from that module, support vector machine module, we're going to import the regressor. All right. We're again going to create our model variable SVR, and we're going to use the RBF kernel for it, and then we're going to fit it based on x and y values. So that has been a success. Now let's predict a value. So let's take 11,000 as our input. Already 11,000 square feet as our input, and let's run that. And we are receiving the answer as 16 16 lakh 35,883. So that's the price, predicted price. And let's visualize this entire plot, right? Yeah, and let's create a smoother curve for this. So let's run this code. So these are all of our support vectors over here, and then based on them, whatever these support vectors, as if we let me zoom into this, yeah, you can see these separate lines at different slopes. All right, this line, this line, this line, and so on. All of these lines are support vectors, and they divide the entire data set into two groups. And then based on the position of our of our input value, how far it is from our support vector, we can predict the price based on that location. So these are modified smoother support vector, and yeah, that's pretty much it. So let's say we had 11,000 over here, right? Yeah, we are given the input as 11,000. So 11,000 is somewhere over here in the middle, all right? And that price goes somewhere over here. So it has to be more than 0.1, and yeah, it's 0.16 nearby 0.16. So yeah, that's pretty much it, how it works. Let's move on to decision tree. Now what is a decision tree? What decision tree does is that it converts your entire y into categories. All right, so let's say the price is from 0 to, let's say, 10 lakh. All right, so it will be, is it less than 1 lakh, is it more than 1 lakh? If it is more than 1 lakh, is it less than 2 lakh, or is it more than 2 lakh? If it is more than 2 lakh, is it less than 3 lakh, is it more than 3 lakh? Right, in that way, in a series of yes or no questions, it will create an entire tree. Now let's say the question is it more than 3 lakh or less than 3 lakh? Now under less than 3 lakh, from 2 lakh to 3 lakh, it will create another range. Is it less than 2 lakh 50, more than 2 lakh 50? Under that, it will again create ranges, and according to that, our prediction will be made. So let me just run this. Again, we're going to be just using one factor for this, that is the living square feet. So x will just be the living square feet, y will be your target. Let's run this. Let's reshape it. And then from scikit-learn.tree, we're gonna import the decision tree regressor. We're gonna create our regressor over here, and we're gonna fit it on x and y values. So let's run that. All right, it has worked. And let's make a prediction for 11,000. And this model, gives us the value of 7,06,000, right, compared to 16 lakh over there. And let's visualize it. Yeah, so this is how your decision tree is. So as you can see over here, all of these uh, square rectangular kind of shapes, all of these 90 degrees, they are based on yes or no. All right, so if you could imagine, if you could revolve this over here, and then right side says yes, left side says no, and based on this entire decision tree we can make a prediction uh, to which side, based on yes no's, yes no's, yes no's, we segregate the entire data, and then whichever region our our input is, based on that we can give a output of the price. So over here we had 11,000, so 11,000 is over here. If you would take it over here, it would be 0.7 something. So that's again that's why it gave us a 70625 value, right? So let's move ahead. Let's take random forest. Now sometimes what happens over here in decision tree is that the model usually overfits or underfits, all right? And that's something that we don't want. So what we do in random forest is that we divide the entire data set into smaller segments as we did in decision tree, and then for each of these segments we create a separate decision tree, all right? So as over here we had one tree which was going from 1 lakh, 2 lakh, 3 lakh, 4 lakh. It was make inside one tree there are multiple nodes, multiple leaves. Instead of doing that, what we'll do is we'll divide the entire tree, we'll divide the entire range into smaller segments, and then within those segments we'll have those separate trees. Now in each tree we'll put our input, whatever output, whatever prediction we receive, we'll take an average out of them. We'll take an average of all of the outputs. So what this will do is, it will, because you are creating smaller decision trees in smaller territories, the probability of it underfitting or overfitting gets reduced, and that's why random forest is a better alternative to decision tree. So let's run that again. Same process. You have to convert them to arrays x and y. Again, we're just taking house price versus your living square feet. And then again, from scikit-learn.ensemble you will import the random forest regressor, and the random state is 0 as before, and the estimators are 10. All right, so over here we'll create 10 decision trees, and based on those 10 we'll have our output. Let's run that. All right, and let's make a prediction for 11,000. And yeah, this prediction brings us to 5,20,000. All right, so that's a bit doable. And yeah, so this is our better graph. All right, so this has been, instead of the problems that you had over here of it making this weird prediction, so that has been tried to be normalized, right, so that it can give a better fit. So that's random forest for you, and that's regression. So I think we are done with regression, and if you have any doubts, send me an email, let me know, or leave down a comment over here. That will be helpful for others as well. Any doubts you have, you can post them down here. Alright, thank you. Thanks for watching, guys. Leave a like if you enjoyed the video. Subscribe for more of such videos. Give me a follow on Twitter at Karia. And if you have any doubts, you can leave them in the comment section below, or you can send me an email at ask.kevinpgaria@gmail.com.